Good morning, guys. Today I wanna take us through the tutorials of PVSys, just some basics and introductions so that we can see a way of moving on. If you want to start, you have to install PVSys software into your machine. As for me, I had already installed it, and this is it. We can open it so that we see a way of moving on. By that time that is opening, we have some other simulation softwares known as PVSol. We have ProfiCAD, we have SmartDraw, we have LiveWire demonstration, amongst others. But for the simulation of solar, we majorly deal in PVSys so that it can give us the desired locations and the required quotations for the materials that we need. In the PVSys, to have grid connected side, we have the standalone side, we have the pumping that are majorly used in the daily, and the most of the institution use these sites so that they can simulate, run and design a proper quotation for their backup or just for the general use. Now I'm just gonna give a brief basic on standalone system. Now, like if we want to do standalone system, we have to have the project name. Now, like here, we're gonna type the project name. Let's say it's Kisi standalone system for Kisi University. Now, having it like this, we need to at least choose a geographical site. Now, like I told you, this is just an example, and I'm working offline. If I was to be working online, then I could have added a geographical site. And after writing this, we need to save our work so that we continue. From there, we can you can decide to add the site using this tab, so that if you are working online, you are in a position to choose anywhere that you want your work to be. Now, like in my installed geographical sites, I'm not seeing Kisi as one of them, but let me just use like Nairobi Wilson Airport as an example, so that we can see a way to go. After clicking on it, we're gonna click on export. The full data of the geographical site is now copied into the okay. Now we have to continue with the work. We click OK. Now, one meteor file in the vicinity, you can select the meteor file. Let's see that we have Nairobi decorated that. The site has been modified. Please save. We click there to save, so that now, after saving our work, we have the orientation the user needs, so that we need to verify all this until a point that we will reach to the simulation site. Now, let's start with the orientation site. In the orientation site, we have the tilt and the azimuth, of which we are nearly at the equatorial regions. We can work between 15 to 30. Now let me decide to work with 18 and azimuth we can work with 67 degrees also. Then we want quick optimization there. Let's work the yearly irradiation yield so that it gives us the correct thing. So from this point we're gonna click OK. User need not defined. Let's define the user needs to continue. Now, like if it's an institution, we're gonna approximate the number of the lamps or the LEDs that the institution is gonna use. Let's say there are 20 LEDs. Then the power consumption can be, let's choose energy saving bulbs of 9 watts each. They will be working for around 12 hours or 8. Let's see, an average of 8 hours. Then the TV, PC, you can see they are around 15. Then the power consumption, let's work out with 250 watts. Then the hours that they are working, around 12 hours, around 14 hours or so. Then for the domestic appliances, let's put that there are 5 domestic appliances. What are they? Totaling to around, let's say, 100 watts, and it will be working for around 4 hours. There we have a fridge. Yeah, an institution can have a fridge already, freezer. Yes, let's say we have 2. Then it's working for how many hours per day? Defined power 24 hours. What's the power? Around 1 kilowatt hour per day. Then we have dish and clothes washers. Let's say this is not there. Other uses of the maybe you can add one other use there to be 2, so that its power to be 50 watt per hour. Hours per day means 12. Yeah, if it's 12, that's number 1. Please define the hourly distribution for second page. And after doing this, we want to do the hourly distribution. The lamps will be like I told you, this is just but a basic introduction. Have the TV, will be working in this scenario. Other uses that, so there we have it. We can click OK to continue. Please define the system. Let's see now the system, how it's gonna be. Now, like in the system, we have to see the storage and every other thing specific. Sort battery by the capacity. Electron. Let's use like electron. Then we want lithium ion battery. Battery is in series 48. Yes, please choose battery model. Let's see, you can use Victron Energy. I just like it. I just like Victron Energy. Okay, but it's now, we need to have a capacity of around 200 or 100 Ah. Which one will give us that? Let's try checking in between if we'll have one that will give us whatever we want. Let's see, power break. Yeah, that's a bit better, giving us 103 ampere hours as the capacity of the battery. After that, we need to number of modules, PV modules. We have it there. We can continue with whatever we want. Let's see the power module. Start by power. We want to go with let's see the favorite or available now. 26 volts watt power. Should be. Yeah, if we have this now, we can see now. We can try looking at the controller. We have Victron controller MPPT. Yeah, we have it there. So thereafter we see that user needs us to do that. We can now read through this to see whatever we want. We don't need a backup. After all this, we can try looking at the simplified sketch. Yeah, wow, this is so nice. Now like this is gonna be the simplified sketch of whatever we should be doing. We have the PV array. Yeah, here we have all the things. We have the, not really, they have suggested a backup generator for our system. We have the regulator there, tamper, and every other thing. We have the user loads. Yeah, so nice. Okay, ready for simulation. Now like you can see everything is now ready. Don't forget to save your work there. Yeah, if it's already saved, you can run the simulation and see. Wow, the simulation is there running, meaning that there are limited errors for our system. Let's wait and see. Yeah, so nice. As we still do our simulation, we can have a quick check on Previsual Premium, one of the solar systems softwares that can be used for the simulation and the design. Oh, I'm using a trial version. Let's just start. There we go. I see what's it's gonna give us when we are still doing that installation. Yeah. Oh, it's taking a bit longer. We need not to abort. Let's just be patient and see whatever it's gonna give us. Taking a bit long, but we'll just have to be patient to wait. Taking too long, man. Okay, let's just wait. It's almost done. It's taking too long. Oh, it's almost done. Let's wait and see whatever it's gonna give us. Oh, it's complete. Now you can see the report. Yeah, now our report is already there with everything. Let's see whatever is there. Models used, that we used total number of PV 35. This is the battery system. Battery pack, that's which items placed in parallel. Yeah, controller, that. Oh, everything is now there for us. And like from there we can save our work. Let's save it to yeah, let's save it there. Okay, you're gonna click there. Now there some other variants that if you still want to work out, you can work. We have the tables, report, predefined graphs. We have the hourly graphs, economic evaluation. Like if you want to determine the quotation of the materials, you can work with the economic evaluation as at that part, and there you go, everything is there. So nice. That's all about the basics of the PVsyst. If you want more detailed things, we're gonna learn much about them as time continues. Let's close it because it's done already. Exit, then save.
Draw down there.